All right, so I just wanted to go over a couple of these word problems from our Conics section review, and we'll start with the problem number 13. And it says a receiver in a parabolic television dish antenna is 3 feet from the vertex and is located at the focus. So we know several things here. We know we're dealing with a parabola. So we know it's either x squared or y squared. And it says that the receiver is 3 feet from the vertex, which is located at the focus. So the focus is 3 feet away from the vertex. Write an equation that represents a cross section, like a slice, of that parabolic television antenna. Assume that the vertex is at the origin and the parabola opens up. So let's put these things on the graph. I've got my vertex. I'm told it opens up and the focus is 3 feet up from here. This is really everything we need to know. We know that this one is a parabola that opens up or down. So our formula that we're going to be plugging into is going to be the one that has x squared. So 4p times y minus k equals x minus h squared. We were told our vertex is at the origin, so that means h is 0 and k is 0. And then based on this information we have, we also know that our parameter is positive 3. And I know it's positive 3 because the focus is 3 units up from the vertex. If it was 3 units down from the vertex, then p would be negative 3. So all we're going to do is go ahead and plug everything in. So 4 times 3, and then y minus 0 equals x minus 0 squared. We'll just kind of clean this up. 12y equals x squared. Don't really need those parentheses, but they don't hurt either. You don't have to graph this one, but it's not bad practice. You put the directrix at y equals negative 3. And then since p is 3, that means the length of the lattice chord is 4 times that. It's 12 units long, which means we'd go 6 to the right and 6 to the left, and then connect our vertex. Okay, number 14 is a problem almost identical to a homework problem that we've had before. And it says an arch is to be constructed in the shape of a semi-ellipse, which is just the top half of an ellipse. The opening is to have a height of 2 feet, and the width is supposed to be 6 feet along the x-axis. Find the coordinates of the foci and write an equation to model the arch. So we're doing two things. We're going to find the foci and write an equation. With conic sections, if you're not told otherwise, life is easier if you make your center at 0, 0. So in this case, we'll go ahead and do that. H equals 0, K equals 0. The opening is supposed to be 2 feet up and then 6 feet wide, which means 3 to the right and 3 to the left. So this is our semi-ellipse. That also tells me that A is 3 and B is 2, because in an ellipse A is always bigger than B. And then the last thing it tells me is that this is horizontal. So knowing that it's horizontal, that tells me that my a squared is going to go under the x term. So we're just going to have x squared and y squared in our numerators, joined with a plus equals 1. And then a squared, because it's horizontal, goes underneath the x squared, and b squared goes underneath the y squared. So that's the equation. That part's easy. What we need to do now is find the coordinates of the foci. Now the foci are just points on the major axis, and the major axis is this one here, and they're the points that are c units away. So I'm going to go to the right c or to the left c. And remember, the way that we find that equation is c squared equals a squared minus b squared. You'll get that equation on your formula sheet on the test. And so we'll plug in a and b to find c. So c squared equals a squared is 9, b squared is 4, subtract them, we get 5, and then we'll square root. So c equals square root of 5, which happens to be about 2.2. So if you want to visualize where that is, that's here and here. We're asked to provide the coordinates of the foci. So we're going to take our center coordinates, 0, 0, and we're going to move to the right and left. So this was our center. Then our foci are going to be 0, and we have to do something so that we can move to the right or left. So to the x coordinate, we are going to plus or minus root 5. Now, I probably wouldn't write it like this. My final answer would just be plus or minus root 5, 0 for my foci. But this kind of shows us the process, that it's always based on the center. And in this case, it's horizontal. It moves right and left from the center. If this was a vertical ellipse, we would have added that c value to the y value of our center. Okay, this is our last one, and it has to do with a hyperbola. And there's a vase that has the shape of a hyperbolic cross-section. So this might be a little challenging to visualize, which is why I want to walk through it. The vase is 26 inches tall. It's 4 inches wide at its skinniest part and 8 inches wide at its base. So again, let's make our center at 0, 0. So I'm going to already say that h is 0 and k is 0. And then if the vase is 26 inches tall, then it goes up to 13 and down to negative 13. Then we're told that at its 4 inches wide at its skinniest part. So that's going to be here and here, right 2 and left 2. And those are our vertices. So if these are my vertices, now I know that this hyperbola is going to be horizontal. I also know that my a value is 2. All right, so 8 inches wide at the base. So the base was down here at 13. If it's 8 inches wide, then we'd have to go 4 to the right and 4 to the left. And then the same thing up here, 4 to the right and 4 to the left. So this is the shape of the vase, kind of this curved shape. The hyperbola itself is this whole thing. And so we're just going to write an equation that models that relationship. So what we're missing, we have almost everything we need. We need to find our b value. So we'll do that in just a second. But for now, what you're going to do when you have a problem like this and you have the a value, we don't have the b value, we have nothing that tells us the c value, we're going to have to use a coordinate from the hyperbola. And that's just an x and y value. So this coordinate is 4, 13. That's an x and a y. So let's look at this equation. We've got, it's horizontal, so x squared minus y squared equals 1. A squared is 4. And we don't know what b squared is. So I'm just going to put a b squared right here. Then we're going to plug in for our x and y, 4 and 13. So I'm going to say, all right, 4 squared over 4 minus 13 squared over b squared equals 1. So now this means we only have one variable left. You can solve for that variable. It's a little bit messy on the algebra, but we can do it. So 4 squared is 16, and 16 divided by 4 is just 4. 13 squared is 169, and b squared is just b squared. All right, so I'm trying to solve for b squared. Right now, it's tied up in a fraction. The first thing I'm going to do is subtract this 4. So I get negative 169 over b squared equals negative 3. To get rid of this b squared in the denominator, I'm going to multiply it over here. So now I've got negative 169 equals negative 3b squared. I still like to get b squared by itself, so I'm going to divide by negative 3. These cancel out, and so then I have 169 over 3 equals b squared. Now remember, that's all I needed to find in order to write my equation. So I'm going to go back and plug it in. X squared minus y squared. Now I just leave those x's and y's alone. I just used them to find the b value. And then this is 4. And then your b value is this messy fraction, but it's okay. 169 over 3. So the key on a problem like this is identify what you know and use it to find what you don't know. So we had to use an x and y value to plug in and find our b value. Once you do that, you just use your b squared and plug it in.